When you picture a galaxy, you probably imagine something like this, a beautiful, glowing pinwheel floating in the dark. This shape is incredibly common. Look out into the deep cosmos, and roughly 70% of all the galaxies we can see share this exact same design. We have known about this structure since the 1850s, when astronomers first sketched these patterns using massive stone-supported telescopes. But observing them was the easy part. Understanding how they form took another century. Astrophysicists had to figure out why the universe flattens these enormous structures into disks and where those glowing, sweeping arms come from. To find the answers, we have to rethink galaxies, not as painted, solid objects, but as active, flowing fluid systems. Every galaxy begins its life as a massive, shapeless cloud of gas drifting slowly through space. Over time, gravity pulls this messy nebula inward. As material crashes together, it forces the gas to start spinning around a central axis. If you've ever watched a chef toss a ball of pizza dough into the air, you know what happens next. The physics of that spin forces the material to stretch out and flatten into a wide disk. But a spinning pizza crust is flat and featureless. It doesn't have a distinct glowing spiral pattern carved into it. Gravity and spin explain why a galaxy forms into a flat disk. To explain those majestic arms, we need an entirely different mechanism. Galaxies spin at uneven speeds. Inner stars orbit much faster than outer edges. If spiral arms were fixed objects, this speed difference would tightly wrap them up like cream stirred into coffee, quickly smearing them into featureless rings over billions of years. Because we can clearly see the arms today, astrophysicists realized they cannot be solid objects. Treating the arms as moving waves rather than solid objects solves the winding problem. We can easily visualize this complex cosmic phenomenon by looking at a highway traffic jam viewed from a helicopter. Individual cars drive at normal speeds. Then they hit the congestion. They slow down and pack tightly, then accelerate out the other side. The traffic jam itself persists for hours, slowly creeping down the highway, even though the specific cars trapped inside are constantly changing. In a galaxy, the spiral arms are the moving traffic jams, and the individual stars and gas clouds are the cars driving through them. These arms are slow-moving ripples of gravity traveling through the flat disk, temporarily concentrating whatever matter passes through them. To understand why these ripples glow so brightly, we have to look at what happens to the loose interstellar gas caught in the squeeze. When that loose gas gets caught in the high-density traffic jam, it gets compressed. That intense pressure triggers gravitational collapse, rapidly igniting brilliant newborn stars. These newborn stars are super bright and burn through their fuel very quickly. They burn out and die before they can exit the traffic jam, meaning their light is entirely contained within the arm. Spiral arms are visible not because they contain all the stars in a galaxy, but because they are the active nurseries illuminating the newest, brightest ones. A galaxy's shape comes from two mechanisms working together. The pizza dough spin creates the flat canvas, and the cosmic traffic jam paints the glowing arms. This image shows the visual proof. The dark dust lanes on the inner edge are the cold gas approaching the traffic jam, followed immediately by bright pink regions of new star formation. Our own Milky Way is currently undergoing this exact same dynamic process. The majestic spiral we see through a telescope